Okay, that's right. All right, so let's continue with the real numbers today. So last time we learned everything about the signs, the rules of the signs of all the operations. That's very important. And we introduced real numbers, what they mean and what they're made of, natural, integers, rational, and so on. So in addition to the rules of the signs, we have other rules. We call them properties. Properties and basically how to deal with those numbers. Not just the rules of the signs, but other rules that we need when we try to simplify expressions with multiple numbers, multiple variables, and operations. So we have those properties. So we call them the properties for real numbers. We have a few of them, about six of them. They're pretty simple. Each has its own name and it's used for a specific purpose. So let's first introduce expressions. I don't know we've talked about expressions yet. We're going to talk about expressions, what they mean. Then we'll see, talk about the properties that I mentioned. We call these algebraic expressions. Did we mention these already? Did we mention the algebraic expressions previously, the X and Y's? Oh, I think we did.
Yes, we did.
Yeah, we did the evaluation and everything. All right, so we already know what expressions are. Let's see how to simplify them today. Let's see how to simplify these expressions using the properties. Okay, so basically we said, what do we mean by an algebraic expression again? In a couple of words.
It'll have an equal sign.
That would be an equation. Equation has an equal sign. Expression does not
No,
have
I'm
an
saying
equal
it
sign.
doesn't. That's why I said it don't have one.
Okay, that's right. That's right. It doesn't have an equal sign. And what is it made of? What are they
X.
made of?
Numbers and letters.
Numbers and letters.
That's right. Numbers, combination of numbers. And letters, we also call them variables, numbers and letters. So that's what an algebraic expression is. We learned the evaluation last time and checking equations. Let's see how to simplify them. So whenever we have, for example, let's say 5x minus 2y and plus 3x, maybe minus 8y. So this is an expression that's made of terms. We have a few terms here. There are 4. 1, 2, 3, 4. As you can see, they all have variables. So we have x variables and we have y variables. So simplifying expressions simply means basically combining similar terms or similar variables. So we can make the expression shorter and simpler. That's the purpose of simplifying. Sometimes it doesn't have to be long. It can just be a simple, easy expression. For example, here, what can we combine together in order to simplify this?
The 2x
5x and 3x.
That's right. So we can combine these, let's say x. And so 5x basically, well, you can write them next to each other first. If you want to write them next to each other first, so you can take this. And next to it, we can write the other term. So basically we move the term next to the similar term. Each term has a number here, what a coefficient with the sign. So we move that over. At the same time, we can combine these together. So we're going to take this, we're going to take that term with the coefficient with the sign. I'm going to put it next to this one because they both like terms that have the same variable, same power. And then we just combine them. So 8 of something plus 3 of the same thing. We just basically add them. X is unknown, is a variable. It could be anything. It could be money, people, fruits, whatever. So 8, whatever this is, for example, dollars plus $3, it would be $8 or 8x. Then we combine these two, same way. So when we combine, we're actually adding and subtracting. So we're using the rules that we learned last time of addition and subtraction. So combining is basically addition and subtraction. What is -2 here minus 8? -2 minus 8 would be, based on the signs, everything we learned last time. Negative.
-10.
That's right. -10. And the variable. This was class 5 plus 3. And that's it. So this is basically better than this. See, already we cut it in half basically. Instead of 4 terms, you only have 2. That's why we simplified. So the rule we used here is called we call this commutative property. That's the first rule. A rule that allows us to do this, move things around and combine them together. We call that the commutative. Okay, so the commutative property, what it means is maybe basically moving things around so we can combine them. So that's the first one. In a simpler example, when you say, for example, 8 plus 5 or 8 plus 6, it is the same as 6 plus 3. Okay, 8 plus 6 is the same as 6 plus 3. I mean, 8 plus 6, 6 plus 8. Okay, so you can add them this way, you can add them this way. It's going to be the same result. That's basically what the commutative property is. That's what we did here. We moved things around. So you can move 6 to the front or to the back. It's still going to be the same result, for example, 14. So we use the commutative property to move things around. And that also applies to multiplication. For example, if you're doing 3 multiply 4, it's the same as 4 times 3. So the order doesn't matter. The order doesn't matter when you multiply and add. Or you can just move terms around to combine them. So this will be 12. Okay, so that's what we call the commutative property. This one we call it of addition because it applies to addition and multiplication. And this one is, of course, of multiplication. Okay, we have 2 of them. So the commutative property applies to addition and subtraction, and obviously it does not apply to subtraction. For example, if you say 5 minus 2, is it the same as 2 minus 5? Is 5 minus 2 the same?
No.
No.
Exactly. So this does not apply to the subtraction. It also does not apply to division. For example, if you do 4 divided by 2 is not the same as 2 divided by 4. They're different. This is equal to 2. This is basically a half, 1/2. Okay, so that does not apply to these 2. It only applies to the addition and multiplication. Feel free to move things around. It's fine. That's what the commutative property does basically. Another simple property. We have a bunch of them, about 6 or 7 of them, but each one has a name, like I said, and does something different. The other one is called the associative property. You may have seen this one before. Okay, so associative property simply means that it's not exactly like this, a lot different. So when you add, for example, 3 numbers, you can add these 3 numbers in at least 2 different ways. Okay, so it doesn't have to be this plus this plus this. We can do this in a couple of different ways. For example, we may add these 2 first, and then add the other 2 first. Either way, we should get the same result. So according to the order of operations, what do we do first here to simplify that? The left side?
The 3 plus 2?
That's right. So the parentheses. So because of PEMDAS, parentheses have basically priority over everything else. So that's 5. And you add this to 5, we get 10. On the other side, the same thing, we have to start from the parentheses. That's the first thing we do when you evaluate expressions. And this would be 7. You bring the other 3 down. As you can see, the final result is the same. Okay, the final result looks the same. Even though we did it in slightly different ways, that's because of the parentheses. We can do it different ways and still get the same result. So this is what we call the associative property. This one is of addition. And again, it does also applies to multiplication. Same way, almost the exact same way. Going to say an example. But do not confuse the two. They're different. Here, we change the order of the numbers. We change the positions of the numbers or the terms. Here, we only move the parentheses. We do not move the numbers. Numbers are technically still in the same order, but the parentheses change the order because they have to be done first. Let's see that this also applies to multiplication. So you may have 4 times 3 times, for example, 2. Okay, so that's a different example. And again, we can do this in a couple of different problems or ways. So we may start here, for example, or we may start with these two instead. And the result, the final result should be the same. So the parentheses again, first that's 12 times 2, which is 24. And here, if we start from here, that would be 6 times 4, which is 24. See, the end result is the same. So again, that's called the associative property of multiplication. Okay, associative property. This one is addition. This is for multiplication. Put these two together here. And that's our second rule. Very simple. That's all it does. So we switch the order by changing the parentheses. Number 3 is also a simple one. So this one is called the distributive property, which is basically a multiplication. Okay, distributive property, just a multiplication. Pretty sure you've seen it before. Here's what happens. So for example, if you have 5, you have parentheses, and inside the parentheses, you may have some numbers or variables, for example, x plus 3. Okay, so this basically means to multiply. So this is a multiplication here. And the multiplication is right here. So we distribute what we multiply. So it's 5 multiply. There's nothing in between. That means it's a multiplication, as we saw before with the other operations. And this needs to be multiplied by whatever is inside the parentheses. The first one is 5 times x.
So it would be 5x.
That's right. And also we multiply this way. So 1 and then 2, 5 times 3. As we mentioned before with the multiplication, sometimes we use a period here as a multiplication, not as a decimal point, but as a multiplication. The reason why is because we have x here, we don't want to put multiplication that kind of looks like x. So we would be using a dot as a multiplication often. So now we can say 5 times x, that's 5x. And 5 times 3, that's 50. Okay, so this is called the distributive property, which basically means multiplication. Whatever is in front of the parentheses multiplies by what's inside the parentheses. This could be a positive number, could be a negative number. For example, this, -2, maybe 3x inside, -1, for example. Okay, so what you do again is, there is a multiplication here, an invisible one, as we discussed last time. And we distribute, multiply twice. Multiply this way, that way. So it is a multiplication. Okay, so use the rules of multiplication that we learned last time. So when you distribute, we use the learn of multiplication. When we combine, like we did here, when we combine, basically we're adding and subtracting. But this is a multiplication as we learned last time, and we distribute that using the rules of multiplication. So what do we get from the first multiplication? we times these two.
Negative
Negative
6.
6.
That's right. So negative 2 times positive 3, that's negative 6x. And then the other multiplication, negative 2 times negative 1, which is
Positive 2.
positive 2. Positive. So negative times negative, as we saw last time, is positive. Positive times a negative is always negative. So that with the distributive property we use in this. Don't confuse these with the addition rules and subtraction. Those are different. We use them when we combine. Another form of this, another example is sometimes you don't see a number in front of the parentheses. You may see just a sign, just a minus, for example, and maybe something inside like negative 5x plus 3. So that's also a distribution. So as we said last time when we talked about the double negative, you can think of this negative as a negative 1 here. Okay, think of this as an invisible negative 1. Down, we're going to do the same thing we did here. So negative 2 times this. And also negative 1. Same way we multiply, we're going to distribute this minus over. So what do we get?
5.
5.
Positive 5x.
That's right.
X.
Negative times a negative is positive.
It's
You don't have to write the
going
plus.
to be a 3.
Negative 3.
That's right. You don't have to write the plus. Someone has background noise. Please mute your mic. Whoever has the speaker on, please mute your mic. Someone has background. Thank you. So negative times a negative is positive 5x here. What else? What's the other multiplication?
Negative 3.
That's right. Negative 1 times positive 3, that's negative. No need to write this plus, but I just want to show you that we times them. So remember, when you distribute, it's a multiplication, use the multiplication rules. And okay, so that's the distributive property. Let's move on to another one, number 4. So we have a bunch of them again, just remember the names. The other one is called the, what is this number? This was number 3. And this should be number 4. So number 4. It's called the identity. The identity property of real numbers. Identity property. Property of real numbers. It's a very simple property. All it means is, for example, we have 2 of them. So there's one of, as always, of addition. So what it means is if you take any number, any real number, positive, negative, decimal, fraction, anything, any real number basically, and you add 0 to it, you won't change. So we will not get affected. It's the same as 0 plus 3. Nothing changes, it's 3. So adding 0 to anything is basically, does not change the thing. Whatever the number is, for example.
Is identity property?
That's right, identity. Okay, so for any real number x, any like positive, negative, decimal, whatever, if you add 0 to it, it will not be affected. So what is, for example, x plus 0, what is that equal to? Any number plus 0 will be
0.
X.
not x, it will be x. The number doesn't change the 3. That's right. It's the same as 0 plus 3, which is, plus x. So it's x. Adding 0 again does not affect the number stays the same. Whatever the number is, x in this case stays x. So that's the one of addition. We have one for multiplication. So this we say that 0 is the identity of addition. Okay, again, because 0 does not affect addition, we call this we say that 0 is the identity of addition. And
Where is that the identity of what?
of addition, just a plus. It's a plus sign. Okay, so the identity property of addition. So 0 is the identity of addition. In the same way, if 0 is the identity of addition, if you think about multiplication, what is the identity of that? If 0 is for addition, for multiplication, what is it?
1.
Okay,
1.
the 1, that's right. So the 1 does not affect multiplication. If you take any number, you times that number by 1, it would be the same as 1 times that number, which is going to be 5. It does not change. For any real number x times 1 is the same as x as 1 times x, which is
1.
X.
is x, that's right. Anything times 1 is itself, so it's x. So 1 or 0, it is the identity of addition. We say 1 is the identity,
Of multiplication.
that's right, identity of multiplication. That's right, so that's important. Okay, so that's basically what the identity property means. That's all it means. It's very simple, easy to remember. So that's our fourth property, distributive identity. There's another one called, the fifth one here should be the inverse. The inverse property of real numbers. It's also pretty simple. So there's also two here. There's one of addition. And the other one is for multiplication. So let's do the addition one first. So basically, when you take any number from the number line we talked about last time, each number has an opposite on the other side. For example, 3 or positive 3. It has an opposite on the
Minus
number
3.
line.
Negative
That's
3.
right. Exactly. So positive 3. The opposite of it, the opposite of it is called is negative 3. Any number has basically an opposite. If it's positive, it has a negative. If it's a negative, it has a positive. And the inverse property basically says if you take a number, combine with its opposite, what happens?
0.
Is that equals to 0. That's right. They cancel each other out. If the numbers look the same, but the signs are opposites, so no sign wins here, as we did last time when we saw the rules. Basically, nobody wins it. They cancel each other out. You get 0. So that applies to any real number. For example, for any real number, negative x, whatever x might be, what is the opposite of it?
Positive X.
That's right, that is positive x. And again, if you combine negative, whatever number it is, and the positive version of that number, this would be
0.
Negative.
0. No, they cancel each other out. It's always going to be 0 here. Because if you give and take, for example, same amount or whatever, it's 0. So if you take, or if you give someone, for example, $5 and you take $5 back, so one is plus, one is a minus, and they cancel each other out. So basically, it's like you cancel the transaction. So there's no.
It's like nothing ever
nothing left.
happened, right?
That's right. So it's like you cancel the transaction, and the result is 0. The outcome is 0. Okay, so for any real number, whatever number it is, decimal or fraction or a whole number, there's always an opposite to it. And if you combine the two, it always cancels out. And you cancel each other out, and the result is 0. So that's what we call the inverse property of addition. Of addition, we take a number and the opposite, they cancel out. We have one for multiplication. It's a little different. So for multiplication, what we do is, so we take the not the opposite this time. We don't take the opposite of a number. Instead, we take the reciprocal of a number. For example, this number, we take the reciprocal, which is not
4/3.
4/3.
That is right. So the reciprocal is when you flip it. So reciprocal.
4/3.
That's right. So you flip it upside down, not the opposite. The opposite, you switch the sign here. We flip it, becomes 4/3. And the rule here says, so because it's the inverse property of multiplications, we multiply the two. If we multiply the two, what do you think we get if we multiply the two? A number and its reciprocal.
1.
1. That's right.
Is it
Because it's
one?
always, that's right. It's always going to be the same multiplication over itself. So 3 times 4, 3 times 4. Always going to be like this. 12/12 or whatever the numbers you're multiplying.
That's gonna be a whole.
That's right. It's always going to be same. Basically, this comes into itself once. It's always going to be a whole, yeah. Because of the reciprocal, because you have the same numbers at the top multiplied by the same number at the bottom. As we saw with the multiplication of fractions, we multiply the numerators together, we multiply the denominators together. So it's always going to be 1. You don't even need to do this multiplication and simplify it. If you see a number, you multiply by its reciprocal, you can just say 1 right away. You don't need to do the division itself. For example, if you have,
To do the reciprocal of a in the multiplication case, is only with fractions, or it can be
could be any number.
whole number.
It could be a whole number, and we'll flip it. I'm going to see an example of that. After this, we'll see an example of that.
All right, because every whole number has a 1 under them.
Exactly. And that one, you
Yeah.
flip it, it becomes 1 over something.
Okay.
Right? So, so again, we don't even have to do the multiplication here. You can just say 1 right away. For example, if you have 37 over, I don't know, 49. And you times this by, what is the reciprocal of 37 over 49?
49/37.
That's right. And now, what is this multiplication equal to?
1.
That's 1, that's right. No need to do any math because it's basically the same thing, okay? What you can think of it this way, we cancel this and this, we cancel those two, nothing left but 1. Just like we did when we multiplied fractions and we simplified. So it's always going to be 1, and it should save time without having to do the multiplication and having to simplify. So the number could be like this, could be a fraction already, but sometimes it could be just could be a whole number, for example, 5. What x in general, for any real number x. What is the reciprocal of x?
1 over x.
Over X.
That's right. So reciprocal. So this basically, when you see any number like this, as we said last time, we can take any whole number, turn it into a fraction. Now we can get the reciprocal by flipping it. So it's going to be 1 over x. And of course, if you times x by its reciprocal, so x times its reciprocal would be
1.
1. Always going to be 1, or you can think of it this way. You cancel the x and x, you have 1 left. That's basically the inverse property. And this can be very useful. All these rules now, when we use them together with other things, we simplify like long expressions. So cancel stuff out. You can cancel two opposites. You can cancel something like this into 1. So that's what we basically, that's what we need to do to simplify expressions. That's what this is all about today, using those properties to simplify. These expressions have variables, not just numbers. It's not just the order of operations, but we use the properties of real numbers to simplify them. So that's the inverse property. So of addition, we use the opposite. Of multiplication, we use the reciprocal. And the last one, any questions here, everybody, before we go to the last property?
No.
Okay, everybody else, any questions about these?
No question.
No.
Okay. So very simple, as you can see, just they have these fancy names. So try not to confuse them. You know, remember what exactly each one does, because you may see a question that says, give an example of the property or name the property. So, or complete something, complete an expression. So make sure you know what you're doing. Okay, so okay, what else? So one more. The last one here is called the, so we're going to call this number, number 6. So number 6 is called the absolute value. Another important property, absolute. It's very important too. And you will see this in college algebra also. You'll see it quite often in equations and with other things. So maybe you may have heard of it, you may have seen it before. Does anybody know what is an absolute value, or what does it look like, or what it does? Any ideas? The absolute value, or at least the symbol of it. Does anybody know the symbol of the absolute value? Okay,
Isn't it
so
like a line going down?
That's-
horizontal
Is
line?
it the 2 lines?
the 2 lines, that's right, the 2
Yeah, and the
vertical
number
lines.
in between? Is it?
That's right,
Yes.
that's
Okay.
right. So just 2 lines, not brackets, just 2 vertical lines. So we call this the absolute value. That's the symbol of it, the absolute value. What it does is pretty simple. So there's always something inside of it. It's like, not exactly like parentheses, but what they do is inside of them, you'll find a number, or you find an expression or an operation, or you may find just a number. For example, the absolute value. We say the
And that
absolute
number
value of
It's always
negative.
positive.
There's always positive. That's right. So the absolute value, we say the absolute value of what's inside, not the outside. The outside is not affected by the absolute value. So it turns whatever is inside of it positive. And if it's already positive, it stays positive. If it's already positive, for example, 5, it stays positive 5. Okay, so we read it like this. Again, the absolute value. Okay, the absolute value of the inside is, in this case of -3, is positive 3. And again, it doesn't always flip the sign, okay? It's not like the inverse. I mean, like the inverse property of addition. The opposite means the opposite sign. If it's positive, turns into negative, negative turns into positive. Don't confuse that with the absolute value. It only makes negatives into positives. The positives, they stay positive. Sometimes it could be 0 inside. 0 doesn't have a sign, it's neutral, so it stays the same. It doesn't turn positive or negative, it just stays like that. So the absolute value of -3 is +3. Here you may say the absolute value of 5 is itself, basically it's 5. Okay, so that's important about the absolute value. So the outcome is always positive or 0, but we can never be negative. It's against the definition. So the absolute value, let's say the absolute value of something, so value is either positive or 0. Okay, so we can't have a negative number here outside of it. Its purpose is basically to get rid of the negative if it exists in a number. And you may see it not by itself, it could be combined with other expressions. So these are separate problems. Just like the parentheses, you could have a whole expression. You may have, for example, -2, absolute value of maybe 4 minus 7, maybe even something else. You may add this to something or multiply it by something else. So let's say maybe let's see, plus 10. So the thing with the absolute value has to be done first also, just like the parentheses. They're not exactly parentheses. Part of it is parentheses, at least the order of operations, but it turns whatever is inside it makes it positive. Unlike the parentheses, they don't change the sign. The parentheses don't change the sign, but the absolute value does change the sign of what's inside of it. It basically makes it positive if it's not positive already. But the order, again, it's just like PEMDAS. We evaluate the inside first. Evaluate the inside first completely like this until we get either a positive number or 0. Then once you get rid of it, then you continue solving or simplifying using the order of operations. So we're going to start inside here. What do we get?
Negative 3.
Exactly. So that's negative 3. We still have the absolute value plus 10. And what else? So we continue with the absolute value. You have to simplify it again. The absolute
it's
value of
3.
negative 3.
So three,
Positive 3.
Positive.
The negative 2 will have to put it.
That's right. So, and the operation here between 2 and the absolute value is a multiplication, just like the parentheses. So this is
Right.
invisible 2 here. So now this is negative 2. We bring it down. And we multiply it by the result of this, which is positive. So it only affects. So it does not affect what's. Please mute your mic, whoever has background noise. So the absolute value only affects what's inside of it, not the outside. So this negative stays a negative, as you can see. Bring the 10 down. Okay, and what do we do next?
Multiply.
we multiply negative 2 times 3.
Exactly. So once you get rid of the absolute value, the rest just follow the order of operations. So negative 6.
Negative 6.
It's negative 6 plus
Okay.
10 is what? 21, negative 21?
4.
4. That's right, positive 4. So the sign of the higher number and the difference of the 2, as we did last time. Okay, so if you see it again, just follow the order of operations, work inside of it if you have to. Here's another one. You may see something like this, negative 1 minus 2. The absolute values are these, the outside. So what do we do first again?
The negative 1 and negative
Inside.
What is inside?
That's right, negative 3. So you bring this over, see this? It's not part of the thing, it's outside, so it does not affect, or it is not affected by this. Then you keep simplifying again. The absolute value of negative 3 is
3.
3.
So it's a negative 3. So
Negative.
negative 3.
So you gotta bring, that's right, so you gotta bring this negative down. And do not distribute it, okay? These are not parentheses. We saw last time with double negative, we multiply. For example, if you have negative 2, these are parentheses. What is this equal to?
Positive 2.
Positive 2.
That's right. That's right. So this is a double negative. That's right. We multiply it into a positive. But do not do that with the absolute value. It's not negative times a negative. As you can see, it doesn't turn into a positive. Turn the negative into the absolute value into a positive, and the negative stays the same. Basically, this negative here, we brought it down here. And everything else with them should be the same as parentheses. Okay, with the absolute value, whatever you do with parentheses. Same order of operations, except that the inside becomes positive. It's not positive over. So these are your properties. How many? 6 of them. So these are basically you may say the rules or the guidelines that we use to deal with real numbers and simplifying them and everything. There's a lot of rules here. When you combine them together, they can make long expressions much simpler and simplified, as we're going to see next, when we combine multiple operations together. These are just the rules. So now let's actually see how to use them at the same time, combine, use more than one of them at the same time to simplify something. Basically, like we did here. So just a brief example, you can have something like this, maybe some parentheses. Let's see how to apply these rules to simplify that. Okay, any questions about these rules, everybody? This was number one. Maybe we may call this number 2. Let me know if you have any questions, everybody, before we move on to the next part.
Apparently everything's clear.
All
Can you show me, teacher? Sorry, the last part, please.
Here,
The last part, that one.
this one.
Okay.
Yes. So
Yes,
if you
give me one
have parentheses, you can multiply the two signs. You can say negative
Okay,
times a
teacher.
negative is a double negative. But if you don't have parentheses, if you have absolute value, do not multiply. Do not multiply. First, this becomes positive. The absolute value of -3 becomes 3. You bring this sign down. That's why we have -3. Okay, so don't confuse the two, the parentheses and the absolute value. Okay, so simplifying expressions. We're going to see some more examples, longer ones, with more operations and variables. So we saw the earlier example, we combine the x together, the y's together. You may also have some parentheses in the expressions, just like we did earlier with the distributive property. So you may have, for example, 2x minus 5 plus 8x. So we're going to try to make this smaller and simpler, where if possible. You can even put a number here, for example, -1. So that's a longer expression, and we're going to use at least one of these or a couple of them to hopefully make it small and shorter without the
Combine the
parentheses.
x.
We can combine the x. That's one of the steps. But
Or
what is the-
distribute. Do 3 times 2x and then 3 times -5.
Exactly.
I think
so
you
we
have
need
to get it
distribute.
out of the parentheses first, don't you?
That's right. So that's what we do when we distribute. Basically, we get rid of the parentheses. That's right. Just like we did here. So if you have parentheses, distribute them. You may try to add inside. If you have anything that adds up, you can try to add it. For example, if you have 5x plus 5x or something, you can add them. Just like pandas. Then you go to the multiplication, the distributive property. So if you see parentheses, you got to clear them first. That's important. So clear the parentheses or distribute. Distribute first. And when you distribute, it's a multiplication. So what do we get from that?
6x minus 15
That's right. 6x.
plus 8x minus 1.
That's right. -1. That's good. So we know that the parentheses are gone.
So
next
now
step.
you can add 6x and 8x, right?
That's right. So now we can combine what we call like terms.
So that's 14x minus.
14 and
right.
-15.
Correct. So we have these. It has to be the same variable. Okay, make sure it's the same variable. Also the same power, which is invisible here. It has the same variable and same power. Those we call like terms. Okay, we can combine them together. We can add them together. At the same time, we can combine. That's right. Same time, we can combine these numbers. You don't have variables, you just numbers or constants. They can combine. So we can get 6x, not 6x, but 6x combined with this. Basically, we move. It's like moving this next to it, as we did earlier. That's the commutative property. You can change move things around. So basically, we're moving this term here with the sign.
So
Right,
that's
move this over.
plus
That's
x.
It's
right.
gonna be 14x.
That's right. At the same time, we can move the -15 next to this number. So when you move a number or a term, we call them terms. Make sure you move that
-15
sign.
plus 8.
That's right. So one way to look at it, you may say 6 minus 50. That's one way, but even better to look at it as positive 6x, -15, another term, positive 8x, -1. So when you're moving things around, move them with the signs and the numbers. And combine them, combine the like terms. So this 6 of something plus
14x
x
minus
something.
16.
Jesus.
That's right. That's right. And this will be minus or negative 60. As you can see, so this is much better than, see how long this one was? With the, it looks complex at least with the parentheses and everything, but it's actually, we can do it and reduce it into this. It's still the same amount. It's still the same quantity, whatever the quantity is, but this is much simpler. It's like a reducing fractions when we had, for example, 120 over, I don't know, 180. That's a big fraction. You can cancel the zeros, divide both by 6. If you divide by 6, you get 2. Divided by 6, you get 3. It's the same quantity, they're equal, but one of them is simpler than the other. So that's the purpose of simplifying expressions. So to make things easy, to make things easy and simple, that's the purpose of with math in general, is to make things easy, not to make them complex. So parentheses, we distribute them. Okay, distribute first. Again, that's a multiplication. Combine. So when you combine, we're using the addition and subtraction rules. Addition and subtraction. So each one of these has its own rules. So make sure you use the appropriate rules when you multiply and when you add. When you combine, basically, again, using these, you distribute using the multiplication. Okay, so it's one of the examples. So we'll give you another one. Let's put in maybe some more parentheses. So you could have, let's say, something like -5, maybe -4x plus 1, maybe even another set of parentheses. So that's x here. Another set of parentheses like maybe 2x and maybe -3. Again, it doesn't have to be complex. You don't have to see it as some complex expression, but think about once it's simplified, it turns much clearer and easier to see, just like this one here. All right, so what would you do first here?
The distribution.
Negative 5 times negative 4x.
That's right. Both at the same time. I distribute this. Think of the minus again as a -1. Distribute that. So that's the first thing. Before you combine anything, you distribute. So this would be
20.
Negative,
okay.
yeah, 20, sorry.
20x. All right. And
Minus 5. Minus 5.
let's try -5. And then
Minus 2x.
okay. Finally,
Plus 3.
plus, exactly. And now, once we distribute, the next step is to
Combine your like.
that's right, combine. So here we multiply. We're just going to combine, add and subtract. You may write them. You may write, you see how you move this next to this and move it to -15. You can do that, or you can just add them right away without even writing them next to each other. For example, you can do this right away. You can say it's +20 and a -2. That would be
18x.
That's right. So we have +20 -2, that's 18x. Same time you may say, so this is a -5. We're going to combine that with
-2.
that's right, -5 plus +3 is -2.
Okay.
And that's it. See this whole thing here, it's basically this simple. So it doesn't have to stay this complex or this long. And that's it. This is much better. A much better answer than to leave. For example, if you had an answer that looks like this, is much better. Again, just like simplifying fractions or any other expression of numbers. So the purpose is to make things easy and simple. Okay, everybody, any questions about any of these? Everyone, any questions so far?
No questions from me.
Okay, everybody else, please
No
let me know if you have any questions.
No question.
All right.
Hello.
Let's try something different.
Yeah.
Please mute your mic.
Mhm.
Everybody.
Yeah. Good.
Let's do something a little different. So you may see something like this sometimes. So 3x to the fourth, maybe negative 2x to the third. Okay, see some different powers, different variables, but it's not a problem. We can still simplify things like that. Maybe 4x to the third. And finally, maybe negative 7x. Again, the question here is simplify. So every question or every problem has instructions, always read instructions on the question itself. That tells you basically what to do. It's a lot of things you can do with expressions like we did last time. We can evaluate them, we can add them, subtract, we can simplify. So always see the instructions. That basically has half of the answer when you read the instructions, so you don't do the wrong thing or waste time doing the wrong thing. All right, so what do you think we can combine here?
The
Roberta?
exponents.
3
Plus
and
5x
3x,
minus 7x.
3x4, then minus 2x3 minus
Mhm.
4x3.
Okay, so like terms, they have to have the same what? Like
Yes,
terms?
Exponent, same
Exponents,
power.
same variable.
Exactly, so like terms have the same variable and power. That's very important. It has to be the same variable, like terms, same variable and the power. So you go to the first term, you look at the variable and the power and see if you can find anything with the same thing. There's none, so that stays the same. So just write it down, bring it down. Then you go to the next term. Each term again has a number here, has a variable and a power. A term.
Who's calling you?
So a term again is made of these three things. So the leading number here is called the coefficient. It could be positive, it could be negative, coefficient. The second thing here is of course, the variable itself. It could be x, y, z, whatever. And of course, the exponent or the power. So that's what a term is. Okay, a term, coefficient, the variable, and the power. So make sure when you add two terms, you gotta have the same variable and the same power to be combined into one. If not, they can't add up. They stay different, just like x and y. X and y are different. We can't add them. They're just not the same thing. Okay, we can cross this out. We're done with this. What else do we combine?
Minus 2,
2,
3
to the third
Negative
power.
third.
minus 4x3.
That's right. These two happen to have the same variable and power, same variable and power. We can add them.
We
We
can
can
add
combine
them.
them. That's right. So we combine basically their coefficients. The coefficient here is -2. The coefficient here is -4. Okay, the coefficient or the leading coefficient is in front of the variable. What do you get from -2 minus 4?
Positive 6x3.
Not so we're doing -2 minus 4.
Negative x, 6x3.
Power.
So we're using the rules of when you combine. Basically, what we're doing here is combine. We use the rules of addition and subtraction. So what is -2 minus 4?
Negative 6.
-6.
That's right, -6. So,
Yeah, of course, -6.
that's right. When we multiply, that's when the negative times a negative turns into a plus, as we did here. Basically, there's a plus 20 here. But if you just combine it, it's an addition and subtraction. It does not turn into a plus. We add them up. So this is -6x to the third. What else?
3.
Plus
Minus
2x. Minus 2x.
That's right. So we have a +5. The coefficient here is +5. Combine this with -7. You get
X.
-2. It's going to be a -2x. X. Can we do anything else to this expression?
No.
Or do we have, there's
No.
no more like terms, right? There's no more like terms to combine. Because the powers are different. You have power 4, you have power 3, you have power 1. So you don't need to do anything. You can't add these two, a 6 and 3 and 6, or add these two, because they are not like terms. So again, like terms have the same variable and power. Each term is made of a coefficient. It just means this number here in the front of it, the variable and the power itself. So that's basically how you combine. Mhm.
If you give us an expression like this to simplify, does it have to be in the same order or can we rearrange it?
Good question. So when you have different powers, the best way to write it is from the highest power to the lowest. 4, 3, 1. It would still be correct if you don't do it, but it's better to arrange the powers or the terms in a descending order. So far, this is good. 3, 4, 1 is good. But if we, for example, this one was here, we would be fine to move it after the 3.
So if I put it as in an ascending way, is it correct too, or you'd rather
the descending is better, from the highest to the lowest.
Okay.
We like to have the highest power first, because that's also called the degree. The highest one, we call it the degree of this expression. We'd rather have that.
So if it was backwards, we still arrange it, right?
Yeah, it would be better. Yeah, definitely better
Okay.
to arrange the terms. Okay, so that's basically how you simplify your expressions, and we're gonna see how to use this to solve equations and do a lot of other things.
I have a question, sorry.
Okay, go ahead.
The minus 2x to the power 3 and minus 4x, that became minus 6x to power 3 is because of both have the same power, or because both have the same negative sign in front of
No, it's because of the same power.
Oh, okay.
Because the
All right.
same variable and power. The variable is the same and also the power.
Oh, variable too. Okay. So the negative or plus or minus sign doesn't matter. I have to go
No.
by power.
Yeah,
Okay.
we also combined these. They had different signs here, but we combined, had different signs.
Okay.
But
Yes.
they have the same variable, power 1. That's why we combine them, not because of the minus and the plus.
Okay. Thank you.
All right. Any other questions, everybody? Just let me know.
I have a question.
Mhm.
When you no power, that means it's one power?
Say it again a little louder. You can get closer to your mic.
Okay, I'm sorry. I see no power, it's one power?
That's right. That's right. If you see a number, any number like this, it doesn't have a power. It's actually a power 1. If you see any letter, Y, A, C, whatever, it has actually a power, invisible 1. There's always at least an invisible 1 power. If it's different than 1, then you would see it. We would write it if it's different than 1. But if it's not, if you don't see it, that doesn't mean it's there. It's actually there. It's invisible. It's 1. Okay, so always, again, make sure you have this. And you can simplify complex things into some shorter and much smaller expressions. Okay, so enough with the properties of exponents here. We've seen enough of
Another
them.
question.
Mhm.
All 3 has the same variable, so we can't do anything with that, or we just
can.
leave it like that?
Yeah,
Okay.
because they're not like terms. They may have the same variable, but in order for them to be like terms, they gotta have the same variable and power.
So the powers, sorry, so the powers are different, that's why we just leave it like that. Okay.
Right. So we can't do anything here because all the powers are different. So we just leave it like this.
Okay. Okay, thank you.
All right. So let me give you some practice. It's your turn now to give this a try by yourself. Let's give you a couple of these, just like we did. So again, watch your signs and basically watch the properties That's basically it, and you can simplify anything. So simplify, that's what the question would say, not evaluate. Evaluate is different, that's what we did last time. So simplify, and you'll see a bunch of terms here, negative 3x plus 7y, for example, minus 2x, minus 8, or 10y. Maybe also 10 minus 2 and 4 minus 6x plus 9x. And then another one. And we have 2x to the third minus 3 . Okay, so this should be good enough. Sums up pretty much all the properties. All right, I'll give you a few minutes to do this by yourself. Again, watch your signs, watch your properties and your pandas, of course. And yeah, and we'll go over this together afterwards. Okay, I'll let you work on this. You may take a short break if you want to before you do the practice. It's been an hour. Take a few minutes and then come back and do the practice. And we'll discuss this together afterwards. So I'll be back in a few minutes.
Professor, before you go, can I ask you?
Mm-hmm.
I am confused about the due date for practice 3. I don't know if it passed or what happened.
Okay, I'll fix it. I'll double check the due dates. I'll see at the end of the class, remind me, and I'll double check, okay?
Okay, but everything we've done is first and the second, right?
Should be, yeah. Should be. But I'm
Okay,
gonna adjust
thank
some
you.
dates there. All right. So see you guys in about 10 minutes or so.
Uh-uh.
Everybody, let's go over these problems. What do we get here for the first one?
Negative 3x minus 5y.
That's right. So this by itself, all these look like terms, all have the same variable power. So 7 minus 2, that's 5. 5 minus 10, b, negative 5y.
Y.
Okay, pretty simple. You can do that basically in one step. Okay, so what about the second one here? What do we need to do first?
Distribute negative 3 times x squared.
The distribution.
That's right. So the distribution, negative 2 over.
I mean, negative 2.
That's right. So before you do the subtraction, it's wrong to do the subtraction first. It's a common mistake. This stays the same. We're not doing the subtraction yet. The multiplication first, the distribution. So this is negative 8 plus
12x.
that's right.
12x.
12x. Bring
Plus
this down. Okay.
Oh, yeah,
what else?
plus the 9x.
You combine.
Let's see, give me 1 second.
So we
Yeah.
2 plus
That's right.
21x.
These two together into 1. These two together, 21x.
Mhm.
Okay, so basically it's technically just doing multiplications and additions, just like the order of operations. The only
Where
thing
you
is
put
we
that?
introduced x.
Okay, so we will want to put the positive sign in front of the 21x, right?
Mhm.
Not an equal
Because
sign.
yeah, because it's one expression, there has to be something between the terms, either plus, minus, parentheses, something has to be there. Okay, so
Right.
combine the sign, so it'll be 2 plus 21x. And the last one here,
Distribute.
that's right. Again, we have a distribution. So again, this stays the same for now. We're not subtracting anything yet. We're not combining anything. So I'm going to distribute this. Negative 3x is
Plus
second.
3x2.
That's right.
Plus 3.
Not plus 3.
No,
Distribute.
minus
F3 minus 3.
Yeah.
Minus 3
That's right. Bring this down.
plus 6x2.
Exactly. Now we see we can, is there anything we can combine here?
Yes.
No,
Yes.
The
nothing to
exponent.
combine.
Yes, negative 3x2 with 6x.
Oh, true.
Will be positive 3x squared.
Positive.
Wait,
That's right.
2x
a minute, I need to hear.
3
3x
plus 3x2 minus 3.
minus
That's
3.
right. That's right. Minus 3. So this doesn't have a like term, stayed the same. These two have the same power and variable. We combine them, minus 3 plus 6. Finally, the 3 here. So these are different.
Why
Wait.
do I have minus 3x to the x square? You have plus 3x square.
So we have negative 3 combined with 6. So negative 3
Yes, right.
plus
But
6 is plus 3. Positive.
oh, so is it going to be? Oh, because you are subtracting, so we are taking plus 3 because
Right. We
plus
combine it.
is
That's
because
right.
6
So
is
we're adding
greater
the
number.
coefficients. Right. So we combine the coefficients, this one and this one. Just like we combined them here also. So 12 and 9 and so on. So we only combine the coefficients when the powers and the variables are the same. So there's addition and subtraction.
No, sir, I have the same answer, but I have minus 3x square And you
It
have
shouldn't
plus
be.
2x. This
It
is
sh-
why I am
It
confused.
shouldn't be. So you have negative
Because you
30.
have to leave the symbol of the greatest number, which is
That's right.
6.
Okay,
That's why
the
it
symbol
says,
of the
yeah.
greater number. Okay, that's, I got
The
it.
sign of the higher number. Yeah.
So yes, we only do plus minus when it's multiplication or division.
Correct. That's right. So
Here,
combine
we take
basically is
the
a
plus sign
negative.
from the 6 square. Okay, got it. Thank you.
Mhm. Correct. So just like we did last time, all those rules, so you apply them here. Okay, everybody else, any other questions? Questions about this?